All right, so today we're taking a deep dive into something that I think is pretty crucial for anyone who uses Linux process management.
Yeah,
We've got a ton of material that explains how processes work,
right.
why it matters,
For sure.
and most importantly, how you can actually take control and manage them yourself.
Exactly.
We're going to try to extract the most essential knowledge from this stuff
Absolutely.
and give you like a practical understanding of Linux process management without,
Yeah.
getting
Get
too bogged down in the weeds.
too in the weeds, yeah.
So why does this even matter to our listeners?
Let's say you're trying to troubleshoot some software that's gone haywire,
Oh, yeah.
or you want to squeeze every ounce of performance out of your system,
Okay.
or maybe you're just curious about what's really going on behind the scenes.
Mm,
Understanding process management gives you that insight and control.
yeah. I think that's really important.
It is.
And the best part is you don't need to be a Linux guru to get this.
No, not at all.
All right, so let's imagine you're at your computer
Okay.
and things are running a little slow.
Uh-oh.
How do you even begin to figure out what's going on?
Well, the first step is to actually see what processes are running.
Okay, so how do we do that?
That's where the pips command comes in.
That's okay.
Yeah, so if you just type pips in your terminal, you'll get a quick glimpse of the processes you've started in that specific terminal.
So like what I'm running right now.
Exactly. You'll probably see things like your shell, which is bash, and the eps command itself.
Okay.
But here's the thing. Each process has a unique identifier called a process ID,
Okay.
or PID for short.
So it's like a tag.
Think of it like a tag the system uses to keep track of each and every program.
That makes sense.
It's essential for managing them,
Okay, so if I want to see every single process running,
not just the ones in your current terminal.
right, all of them.
You need to use the eps command with a few extra options.
Okay, what are those?
It's peek.
Thick.
It
Oh.
will.
Yeah, this command will reveal everything that's going on behind the scenes. So it'll be a long list.
Oh, it can be a very long list.
Okay, but it's worth it.
Absolutely, because it gives you the full picture.
Okay, so what are we looking at in this list?
So you'll see columns like USER, which tells you who started the process.
Okay.
PID, which is that unique ID we talked about.
Right.
%CPU and %mem, which show how much processing power and memory each process is using.
Oh, so we can see what's hogging resources.
Precisely. And then you have the command column, which tells you the name of the program itself.
That's super helpful.
Right.
So let's say we're looking for a specific process,
Okay.
maybe one that we think is causing problems.
Right. How about we use an example?
Sure.
Let's say you're working with Metasploit,
Okay, familiar with that.
and you want to see if it's running and what it's up to.
Got it.
Now, to find Metasploit processes, we can use grep to filter the output of PO.
Okay, so we're combining
Yeah,
commands.
it's super powerful.
Okay, what would that command look like?
You would type PO peep, symbol grep, and then emps console.
Yeah.
That's console. That's the Metasploit console.
Exactly.
Okay.
And when you run that command, you'll see any processes related to Metasploit.
So what kind of things might we see?
Well, you might see the Metasploit console process itself
Right.
and possibly a PostgreSQL database process because Metasploit uses a database.
Okay.
And you know what?
All right.
You'll probably even see the grep command itself in the results because it's also a process.
That's interesting.
It is, right?
Oh, okay. So we can see if Metasploit is running.
And more importantly, you can check its resource usage.
Yeah, by looking at those CPU and memory columns.
Exactly. You can tell if it's gobbling up your system resources.
Which Metasploit can do.
Oh, it definitely can be resource intensive.
So Metasploit is great for a snapshot.
Uh-huh.
But what if we want to see things changing in real time?
Then you need Top.
Okay, top.
Top is like a live dashboard for your processes.
Okay, I like that.
It constantly updates showing you which processes are using the most CPU and memory at that very moment.
So we can see what's causing slowdowns as they happen. Exactly, and you can even interact with top.
Oh, how so?
You can press H or question mark for help,
Okay.
and Q to quit when you're done.
Got it. So PPS for a snapshot, Top for a live view.
You got it.
Now, let's say we've identified a process that's acting up.
Okay.
Can we do anything about it other than just watching it?
Absolutely, we can manage it.
Oh.
Well, one way is to change its priority.
Priority.
Yeah, we can tell the system to give some processes more attention than others.
Interesting. So like a VIP list for processes.
Exactly, and that's where the nice and renice commands come in.
Nice and nice. Okay.
Yeah, think of it like this. Every process has a niceness value.
Niceness value.
Yes, it ranges from -20 to +19.
So a lower number means...
The lower number means higher priority.
So it's less nice.
Less nice to other processes because it's getting preferential treatment.
Gotcha.
The default niceness value is 0.
Okay.
So when you start a program, you can use the nice command to set its initial niceness value.
Give me an example.
Sure. Let's say you have a really important task that you want to run as quickly as possible.
Okay.
You could use the command nice n10 space bin important task.
So we're starting the program at bin important task.
Right. And the nice n10 part tells the system to give it a higher priority.
Got it.
Now, if the process is already running,
Okay.
you can use the rennice command to change its priority on the fly.
And how would we do that?
You would use the command rennice space, the new nice value, and then the PID of the process.
Okay, so for example, if we wanted to lower the priority of a process with PID 1234 to make it more nice.
Right, you would type rennice 20 1234.
Okay, makes sense.
But there's a catch.
What's that?
Only the root user can increase a process's priority using negative nice values.
Oh, so there's a security measure there.
Exactly.
So regular users can't just give their processes top priority.
Right.
Interesting. Okay, so we can set priority when we launch a program. We can change it on the fly with Renise.
Yes.
Can we also change the nice value within top?
You absolutely can.
How do we do that?
While you're in top, just press the R key.
R for Renise.
Exactly. Then enter the PID of the process you want to adjust, and then the new nice value.
Nice. Very convenient.
It is.
Sometimes, though, we just need to stop a process completely.
Ah, yes. Sometimes that's necessary.
Especially if it's causing problems.
Or if it's become unresponsive.
So how do we kill a process?
Well, the aptly named kill command is what you need.
Okay, kill.
Yeah. The basic syntax is kill, then a signal, and then the PID of the process you want to terminate.
A signal.
Yeah, it's like a message you send to the process telling it what to do.
Okay, so what are some common signals?
Well, the default signal is sigterm.
Sigterm.
It's signal number -15.
Okay.
And it's like a polite request for the process to shut down gracefully.
Okay.
But sometimes a process might be stubborn and ignore sigterm.
So what do we do then?
That's when you might need to use sigkill.
Sigkill.
It's signal number 99.
Okay.
And it forces the process to terminate immediately.
So it's like pulling the plug.
Yeah, exactly. But use it with caution.
Because
Because it doesn't give the process a chance to save any data or clean up before it exits.
Got it.
So reserve sigkill for those really unresponsive processes.
Okay, good to know.
Now there's another command called killall,
Kill and kill.
which is useful if you know the name of the process but not its PID.
Okay, so how would we use that?
Let's say you have a process called runaway app that's consuming too many resources.
Right.
You could use the command kill necna9 runaway app.
Okay, so we're using that NICNA9 signal again.
Yes, the sigkill signal to forcefully terminate all processes with that name.
Got it.
And just like with Renaxes, you can also kill processes from within top.
Okay, how do we do that?
You just press the K key and then enter the PID of the process you want to terminate.
Okay, so top is pretty powerful.
It really is a versatile tool.
All right, so we've talked about viewing processes, managing their priority,
Right.
and even killing them.
Yeah.
But what if we want to run a process without it taking over our terminal?
Ah, good question.
Like, let's say it's a long-running task,
Okay.
and we want to be able to use the terminal for other things while it's running.
Absolutely. There's a simple way to do that. You just add an ampersand symbol to the end of the command.
Okay.
So, for example, if you have a command called long process,
Right?
you would type long process space ampersand.
Okay. And that will,
That will run the process in the background.
so it's like sending it off to work on its own.
Exactly. And you'll immediately get your terminal prompt back so you can continue working on other things.
Very cool.
And if you need to bring that background process back to the foreground later,
Okay.
you can use the FG command.
Febby?
Yeah, possibly followed by the job number or the PID of the process.
Okay. And how would we find the job number or PID?
You can use the jobs command to list background jobs or PIS to find the PID.
Got it.
Pretty straightforward.
So now we can run processes in the background and bring them back to the foreground if we need to. But what if we want to schedule a task to run at a specific time in the future?
For that, you need the at command.
Okay, that.
Yeah, it's perfect for automating tasks.
Like what kind of tasks?
Well, anything really like system backups,
Okay.
running scripts, or even just sending yourself a reminder.
So how do we use at?
You type at, followed by the time you want the task to run.
Okay, and how specific can we be with the time?
You can be quite specific.
Like,
You can say at 8 a.m. tomorrow,
Okay.
or at now plus 30 minutes.
So that would be 30 minutes from now.
Exactly. Or even something like at 7:30 p.m. June 15.
Wow, that's pretty flexible.
It is. Once you enter the time, you'll get a special prompt where you type the command you want to run at that scheduled time.
Okay, that makes sense.
So it's like setting an alarm clock for your computer.
I like it.
It's a handy tool.
So to wrap things up,
Okay.
we've covered a lot of ground today.
We have.
We talked about viewing processes with EPS and TOP,
Hmm.
managing their priority with nice and
Right.
terminating them with kill and kill,
Yep.
running them in the background with the ampersand symbol, and bringing them back with FG, and scheduling future tasks with F.
It's a lot, but it's all about giving you control over your system.
Yeah, and it's not as complicated as it might seem at first.
No, not at
No.
all. Once
No.
you get the hang of these basic commands, you'll be able to manage your Linux processes like a pro.
Exactly.
Yeah.
So think about the tasks you do regularly on your computer.
Mm-hmm.
Could you use scheduling to automate some of them?
It's worth considering.
And what other questions come to mind when you think about how your software interacts with the operating system's resources?
Yeah, it's a fascinating world down there.
It really is. And there's always more to learn.
Absolutely.
So until our next deep dive, keep exploring and keep learning.
Keep digging.